We're going to learn how to identify shapes that are similar. We've talked quite a bit about how to determine if something is congruent and what the word congruent means. And similarity is like congruency. Congruent means two shapes are exactly the same size and they are exactly the same shape. Similarity means they are exactly the same shape, but not exactly the same size. So the two shapes, in order to be similar, would have to have the same angle measurements so that they are the same shape, but they would not have the same side measurements. So we could have one shape that was very small and one shape that was very large, but all of the angles would be the same. So when we're asked to determine whether shapes are similar, what we need to know is that similar shapes have all of the same angles. All congruent angles. I'm sure there is a more elegant way to write that, the definition of similar, but that'll do for now. All the angles are congruent, all the angles are the same. So in a triangle, it turns out we don't need to know all three angles to know if two shapes are similar. We can get away with just knowing two of them. And the reason that we only need to know that two of the angles are congruent is because in a triangle, if you know two of the angles, you automatically know what the third angle is because in a triangle, the sum of the three angles is always 180 degrees. That's the triangle sum theorem. The three angles of a triangle all have a sum of 180 degrees. So if I know two of them, it's easy for me to know what the third one is. So the angle-angle similarity postulate, or we sometimes abbreviate it the AA similarity postulate, says if in two triangles, two of the angles are congruent, meaning two of the angles are the same, those triangles are similar because I know the third one's going to be the same also. So when we look at these two triangles here and we're asked to determine are these triangles similar, what we're looking for is do they have two angles that are the same? Well, right away I can see that they have one. They both have an angle that is 100 degrees. The question is, do they have a second angle that is the same? And when I look at the angles that are given, it seems like the answer is no. One of them has an angle that's 45 degrees, and one of them has an angle that's 35 degrees. Those are obviously not the same, but I'm missing an angle for each of them. So I need to figure out what one of those missing angles is, because if angle A, this angle right here, if that angle is equal to 35 degrees, then it means these triangles would be similar under the angle-angle similarity postulate. It means the first triangle would have angles of 135, and the second triangle would also have angles of 100 degrees and 35 degrees. Or if I wanted to, I could check and find out what angle B is and see is angle B 45 degrees? Because if angle B was 45 degrees, then the two triangles would be similar for the same reason. They would have two congruent angles. So I can figure out either one of these. Let's do angle A just because. Let's figure out what angle A is. And so the measure of angle A is going to be equal to 180 when I add it to the two angles that I already know. This is the triangle sum theorem, says if I add all three angles together, I should get 180 degrees. So my justification here is the triangle sum theorem. Triangle sum theorem says all three angles added together, 180 degrees. Okay, well, this is like a two-step problem, basically. Let's go ahead and combine our like terms. Our like terms here are the degrees, the 100 and the 45, I can combine together. So the measure of angle A plus 145 degrees equals 180 degrees. I got that from, you know what, let's be consistent with our colors here. I underlined it in yellow. Let's keep it yellow. Let's do 145 degrees. And this was because I combined like terms. There we go. And then to figure out the measure of angle A, all I have to do now is subtract 145 on each side. So let's do that. Minus 145 degrees on both sides. That will isolate my angle A variable. So the measure of angle A is equal to, and then 180 minus 45 is 35 degrees. Sorry, 180 minus 145. And this is the subtraction property of equality that allows me to do this. So the measure of angle A is 35 degrees. Okay, so if I come back up to my triangles, I now know this angle measurement, angle A, is 35 degrees. So the angle-angle postulate tells me that these two triangles are similar because they have two angles that are the same. They both have angles of 100 and they both have angles of 35. So come right over here to the side and write my answer. These triangles are similar. And I'm going to say they are similar by the postulate we're using, by the angle-angle similarity postulate. That's my justification. How do I know they're similar? Because the angle-angle similarity postulate says the AA similarity postulate because they have two congruent angles. And we are going to be extra specific with our answer and say what those two congruent angles are, 100 degrees and 35 degrees. We want to be as specific in our answer as possible. We're saying not only what the answer to the question is, but how we know that our answer is correct. We're proving how we know our answer is correct. We want to justify every single step of our solution by saying, not only do I know I'm right, but this is the proof that I'm right. The similarity postulate says if I have two angles that are congruent, they are similar, and I just proved step by step how I know that those two angles are congruent.